Okay, good morning.
Good morning.
And happy Monday to everybody. Okay, get that going. Come on. Trying to open the chat screen, my cursor keeps sliding off of it. There we go. All right, so we are here on February 1, and we'll talk about selection and loops. And I should have named that selection and repetition, but oh well. And talk about the background, and then specifically how things work in Java. And most of this is pretty straightforward. I think we'll do selection today and loops on Wednesday. There's not much example code for this module. I've just got 2 files, and we'll go through that. Homework 1 is due tonight. Hopefully you started that over the weekend, so if you have any issues, then you can deal with the issues. If you're having Eclipse issues, you can always back off and write it and compile it and run it using the command prompt like I do. You don't have to, not a requirement that you use Eclipse to finish the homework. If you're having a programming issue, it's best to contact the TAs because there's 3 of them and only 1 of me, and I'm in meetings all day. But you can also contact me. As always with course stuff, if you're going to contact me, do it through Canvas messaging, not through email. Then we have quiz 3, and the lab 2 pre-lab is due on Wednesday, and then the P1 assignment is due on Friday, which is the proposal for the project. And I'm going to put up a sample P1. Actually, I have an old one, and I'll make a new one, and that should be done by Tuesday. And if it's not, yell at me on Wednesday. Okay, so let's walk through this. Selection and repetition. Those are not standard terms, I don't think. I like the term selection and repetition because it applies to all programming languages and all programming paradigms. Not all programming languages allow repetition to occur through loops, which is the main way that it occurs in object-oriented and procedural paradigms. Functional paradigms do not have loops. They use recursion. So repetition captures everybody. As always, check through the outcomes and make sure you have an understanding of these things. And I'll say this several times throughout the semester. There's 5 things every programming language has to do. And the reason I emphasize this a couple times throughout the semester is it brings a wonderful clarity to approaching new languages. And when you learn, in your first class, you either learn MATLAB or C. In your next class, you learn some Java stuff, and then you can go on and learn Python or some other language. But usually, you're gonna want to move on to other languages, or when you're employed somewhere, they're gonna use some other language. And if you understand that these are the 5 critical things that every language has to do, the rest is just window dressing. It's just syntax. In fact, it's generally what we call syntactic sugar. Syntactic sugar, it's sweet for the programmer because it makes life easier, but it does not add any more intrinsic capability to the language. So what do you have to do? What are the 5 things? Well, we have to create and declare variables. We've learned how to do that. We have to bind values to variables. That's assignment. We've learned how to do that. That's what the previous module was about. And then you have to be able to select sections of code to execute. So basically you're turning on and off different sections of your code. And you have to be able to repeat sections of code. Lastly is I/O, which is not a purely computational feature, but if the computer computed something in a forest and nobody heard it, did it really perform a computation question? So I/O for user input and for outputting of the results. Okay. Now, I'm saying that that's what every programming language must do in order to be a fully general computational language. By that, I mean, it can perform any computation that any computer can do. As opposed to languages like HTML, HTML is not a programming language. You really can't do a lot of calculation in HTML. HTML is a formatting language. In fact, what does HTML stand for? Anybody know?
Hypertext markup language.
Hypertext markup language. And what the heck does that word mean? That's a bunch of nice words. What does that mean? Well, prior to viewing everything online, we actually held paper in our hands, like a newspaper. And the way that the newspaper editing process worked is a reporter would write up a column and then send it to the editor, and the editor would literally take a grease pen and mark it up. And rather than having to write everything out, they had shorthand notations for what should happen for marking things up. And it was basically a markup language. It's editing, it's formatting, it's not computation. Well, once things went to online, we had this new thing called hypertext. What does hypertext mean? It means you can click on things and an action happens. You know, usually you click on a link and you go to another page. That's what hypertext is. It's active, it's dynamic, you can do stuff with it. And in order to present the text to people who were using their browsers, they needed to have a standardized way to mark up the text in order to tell the computer how to display it, hence hypertext markup language. Not a programming language. You don't do computation other than fitting words inside of a window, right? Very limited computations, but the program, you can't really program a computation. Even in the later versions of HTML, that stands to be true. So real programming languages need to do these things. Now, what do we need to do? We need to do those 5 things, and selection is one of them. Selection meaning turning on and off pieces of code. Now, why? Why am I saying that is a critical part of a real programming language? Why would you have to be able to turn on and off pieces of code? You all have done it, right? Everyone's written an if then else diagram or block. Why did you do it?
Are you talking about like if statements?
I'm talking about if then else. Yep. And that's the implementation of it. Yes. But basically, what's the purpose of an if then else? It's to turn sections of code on and off. Right. So why do you have if then else? You don't always want, so you can have variable outputs and actions. You don't always want every part to happen. Right. So in text, I'm getting, so you can have variable outputs and actions, and you don't always want every part to happen. And that's right, you have variable outputs and actions. What's going to determine how the actions vary, how the outputs vary? What are you responding to? User input. Thank you, Connor. Very good. So between the 3 of you, I think you nailed it. You don't want the whole program to run. You want the program to be able to turn sections on and off. Why? Because different situations require different actions. Where are you getting those different situations from? User input. Now, when I say user input, most of us are envisioning a human sitting in front of a machine and typing something in or clicking on a link or something like that, because we said the word user. But consider that most, quote, user input is really file input. It's data coming in from a file. So with most software, the software runs up, it grabs a file, you say, hey, run this job on this data, and it goes to that file, and it brings that file in. That's input. So instead of user input, we could say data input. Sometimes the data comes from a human sitting at a computer. Often the data comes from a file. And often these days, the data comes from another computer. So now think about how networks and internets work. Computers are talking to each other, and computers are asking computers to do jobs on their behalf. So the, quote, user or the data input that one computer may be responding to is actually a request from another computer. All of those fall under that general realm of data input. So as the data is different, you need the program to behave differently. And a stupid example, you can go on to, what's it called? Campus Solutions. Hey, I can't remember why it's called that because it doesn't solve anything, right? Campus Solutions. And you can look at your degree program, your degree requirements, and it'll tell you, okay, you have to take these classes. So if I'm an aeronautical engineer, aerospace engineering, then I say, hey, what classes do I have to take to graduate? And it'll tell me. And if you were always getting, no matter what your degree program was, and you said, what do I need to graduate? And it always told you what AEs need to graduate, that's not helpful to you. So instead, what happens? Oh, what do I need to graduate? Well, when you logged in, the Campus Solutions grabbed a file and it said, this student is in this degree program. And when this student asks me what I need to graduate, then I need to go look at the course curricula for that degree program. And I need to look at what courses that specific student has already had. And then I can fill in the blanks and fill in the holes and say, okay, here's what you've already taken. Here's what you still need to take. You're responding to user input. How's it doing that? It's going to be some form of an if then else. It's selection. Same trick for repetition. Why would you need to repeat sections of code? Also a safe system in case of an error. So that's correct, yes. Which is another form of input, yes. Efficiency. How so? Efficiency in what way? Copy paste a bunch of code when you can just repeat it, right? Okay, good. So that's part of it, right? So instead of having long sections of code, you have a short piece of code that gets repeated. Why else? There's more than that.
Like validation of the user inputs.
Okay. I heard user input, and that's what I'm going to glom onto. It's the same trick, user input. User input. You can't, you can't copy paste if you don't know how many repeats you need, and you don't know how many repeats you need until you have user input. So again, both of these are responding to the data input that you're dealing with at the present point in time. Why do you do loops? Think about creating a method or a function that averages a bunch of numbers. And if you knew absolutely you were going to average 3 numbers, you don't need any loops. You add the 3 up, you divide by 3. And then if you knew for a fact you needed 4, you would add 4 and divide by 4. Add the 4 numbers and divide by 4. So if you knew in advance exactly how many numbers you had, that's great. But now if you want to do 5 numbers, well, shoot, that code's starting to get a little long because we're doing 5 additions and then a division. And the same with, think about if it was 100,000 and we did that way, you need 100,000 lines of code, divide by 100,000. That's annoying all by itself. But worse than that, to make that routine the most general as possible, you wouldn't know in advance how many numbers were to be added. Someone gives you a list of numbers and you don't know in advance how many numbers are in that list. So what do? You build a way to do repetition. And you build it in such a way that it will always adapt itself to the length of the list that it got. And, dealing with lists is a major part of programming. There's all kinds of lists in the world. You see these credit card companies, oh, there's been a breach and, 2 million people's data may be at risk. Well, credit card companies have lists of millions of people. Embry-Riddle, even at just Daytona campus, we have like 7,500 students and I think maybe 1,000, 1,500 staff and faculty. So those are lists, and every semester the list of students changes and the length of lists of students changes. So when they're running their reports on, how many freshmen do we have and how many sophomores do we have and all that stuff, they're going to go through that list, and it's a loop, but that loop changes the number of elements changes all the time. So you set up loops or repetition in such a way that it's responsive to the current data that you have. So both of those are really about responding to the current data that you have. One is to turn sections of code on and off, and the other is to do repetition for as long as you need to do it. That's the underlying thing here. Now, having said that, since I'm saying every language must have that, You're going to find these things in every language. They may look radically different from language to language. They may. Most languages have settled on some pretty standardized forms. They may look radically different, though. So be aware that no matter what language you need to learn, these things have got to be there if it's a fully computational language. Okay, selection. If then else. And again, I'm calling it selection. That's me. That's not a standard textbook thing. That's me. I call it selection to remind you of its job. You're selecting pieces of code to turn on and off, to execute and not execute. So as we just discussed, it's about responding to the user input. And the user input could be a human sitting at a computer, or a data file, or another computer talking to another computer. And then we do the if then else form. The basic if then else, by the way, if all you have is an if then else, you can do everything. But God, your code's going to look hideous. So people have developed these other forms, right? If then else if, switch statements, things like that, which we'll talk about. Okay. In order to do an if then else, you need three things. Get my hand in there. Three things. Any guesses? What are they? Or a quick run to my slides so you can look at slide number 5.
You need your if statements.
If statements. And what's in the if statement?
The true or false statements.
The true or false statements. Oh, what do you mean by that?
So like, if true, this goes in. If not, then that goes in.
Ah, okay. Okay. So you've got, you actually listed all three things there. The first thing was you need something to do if you get a true result, right? And then you also need something to do if you get a false result. Let's name that thing that you kind of glossed over. Where did you get the true and false result from?
User input, I guess.
Or specifically though, yeah. Yeah, you're right. It's going to respond to data, to the current data input or user input at the time.
Your starting condition?
Starting condition. Booleans. Someone's saying Booleans. Tell me more about Booleans. Yes, it's going to be not so much a starting condition, but the condition at the moment that the if then else block is executed. Yeah, we can call that a starting condition. I like to reserve that for loops though. Boolean test. Boolean, true false statements. Not just true false statements, but true false questions. Questions that have a true false answer. So you need, first of all, the Boolean test. What's a Boolean test? It's a question that has an answer of true or false, or yes and no. It's actually any two-valued system. True or false is what we want to focus on here. So a Boolean test is a question whose answer is either true or false, not both at the same time. The answer may change from true and false. You know, if you execute your code multiple times, the answer may change from true to false over time, but at any one point in time, you know, the moment you hit that line of code, the answer is going to be either true or false. It can't be maybe, and it can't be meh, and it can't be I don't know, and it can't be both. For example, how many legs do most cows have?
4.
4, right. Now, is that a Boolean test?
No.
No. Why? Because it's a numeric answer. So what if I change it? Do most cows, I'm saying most, not all, do most cows have 4 legs?
Yes.
Yes. So that's a true false question. You can't say, how much does my horse weigh? But you can say, does my horse weigh over 1,000 pounds? That's a true false form. So a Boolean test, the answer has to be true false. And you have to frame this thing in such a way that you're getting a true or false back, which is in terms of data types, this is the Boolean data type. Once you get that done, that thing is going to be true or false. And so you need something to do if it's true and something to do if it's false. Remember those three key things. You might go to some languages where it looks really, really weird. But you know those three things have to be there. And as long as you know those three things have to be there, the rest of it's formatting. The rest of it's just syntax. So you see the examples there. In MATLAB, it says if, and inside parentheses, I put my Boolean test. Then I have a true branch. Then I say else, false branch, and end. In Python on the right, if, test, true branch, else, false branch, no end. They use the line, I think they use indentation as the condition for the endpoint. I like really clear, concise, endings to things like the word end. In C, C++, Java, they've pretty much converged on the same results, which is if inside parentheses, you put your test, open curly bracket. Why open curly bracket? Because what did I tell you the first day? Curly brackets always, always tell you the beginnings and ends of blocks of code. Yeah, some people love that about, so someone said Python not having brackets makes me hate it even more, but people love Python. It's so popular these days. And it's got a lot of tools that help, syntactic sugar that help people out. I would have to program for a while in Python before I was comfortable with the spacing type rule. Perversely, that's a throwback to like old Fortran stuff in the 60s. So that's kind of weird. Anyway. The one in the middle, the Java C, C++. If Boolean test inside parentheses, open curly bracket, true branch, close curly bracket, else, open curly bracket, false branch, close curly bracket. So the curly brackets in Java, remember, always tell you sections of code, blocks of code. The beginnings and endings of class definitions, the beginnings and endings of method definitions, the beginnings and endings now of true and false branches. Inside Excel, by the way, is a fully computational language. It just looks odd. But inside Excel, it looks like that. You say equals if, and then you have your Boolean test, comma, true branch, comma, false branch. You can prove it. Equals if 5 is greater than 3. There's the three elements are there. Test, thing to do if it's true, thing to do if it's false. Excel, not the best programming language. It's a complete programming language. The thing that works with Excel is people can get really good at Excel and they don't even know they're programming. Right? They're doing all kinds of cool stuff with it and they don't even know they're programming. Okay, so that's what to be aware of with if then else's. Everything else is formatting. And when you get down to the issue of just, I just have to remember the syntax, that's why you have your cheat sheets next to you, or when I'm programming, I'll have a Java book next to me to make sure I get the formatting right. Or you guys tend to like to work on the screen, so you can have a Java help page open. Because there's no reason to have to remember everything, every minute piece of formatting for an entire language in your head. That's what references are for. Now, if then else is pretty straightforward stuff. Okay. So Boolean tests. In Java, let's see, what can you do with Boolean tests? The Boolean tests are all questions. A Boolean value is true or false. In the Boolean system, there are only two values, which in this world we're calling true and false. And then the Boolean question has to return or respond with either true or false. And inside of Java, and again, most programming languages, they've adopted this formatting where we say A equal B. That's not a statement, that's a question. You're asking, is A equal to B? Now, why is it equal? Two equal signs. What's the deal with that?
Because if you use one equal sign, it sets one equal to the other.
Right. We've already used one equal sign up, right? That's assignment. If we said A equals B, that's, remember what the equal sign means. It's an operation, it's a command. It's saying set the value of A equal to B. This is a slightly different interpretation than what you get in algebra, where you say, oh, these two things are equal. It's a command saying set the value of A equal to the value of B. Now here, since we've already used up equal, what the heck, they just threw another equal sign in there. So A equal B is a command that's saying, hey, tell me if A is equal to B. And the exclamation point is generally used for the not operator. The not operator reverses, right? So not true is false, not false is true. It just reverses things. So that's A not equal to B. And then of course, A greater than B. What if you need greater than or equal to? Well, how did you do that in algebra? You did it with the greater than sign, backwards on my screen, greater than sign underlined, right? That's how in algebra you said greater than or equal to. And that underlined sign was kind of a mnemonic to remind you of the equal sign. So that's a great thing to use in math class. Unfortunately, not on my keyboard. So instead, greater than followed by an equal sign. And then the same with less than. So those are the basic tests that you can run. They're all questions, not statements. You're asking the question, hey, is A greater than B? Is A greater than or equal to B? And then underneath that are the Boolean operators and or not. So when you study the Boolean system, did everybody have to take CS225 to get in this class, or just, I can't remember. I don't think so.
It's not a prereq.
It
no.
is not a prereq. Okay. How many of you, but many of you have taken it, I guess. I'm in CS222 now. Okay. Oh, who's the instructor?
I took CS 118 last semester and then I got put into this class.
Okay. But what about CS222? I forget her name. Oh no, that's not.
Candle. Mura Laxima. I don't know how to say her name.
Okay. How many sections of 222 are there?
I believe there's only one, and it's an online asynchronous class.
Okay. All right. Oh man, that would be tough. Okay. That's my favorite class, by the way. I don't get to teach it much anymore. Okay. Yeah, you start with set theory. Okay. All right. So anyway, when you get into, those of you that have already taken CS222, you know all about the Boolean operators. Oh yeah. Okay. Yeah. She's our new hire. She's good. Yeah. Okay. Got it. Got it. Thank you. So the idea behind the Boolean system is there's only two values, true and false, and there's only three operators, and or and not. And when you and two things together, then it's true when both things are true. That's the only time it's true. So true and true is equal to true, but true and false is equal to false. False and true is equal to true. And if you think about it, go through some simple examples. Let's see, if I have my car keys and there's gas in the car, I can go somewhere, right? Both of those things have to be true. Otherwise, I'm walking. And the or operator is true if only one of them are true or both are true. Now, this is different than the way we use or in our natural life, like when you're just dealing with everyday life. So true or false is true, false or true is true, but also true and true is also true, or true or true is also true. So with the or operator, only one of them have to be true. Both of them may be true. Yes. Yes, because that's just the Boolean system. And these programming languages are duplicating the Boolean system. So that's just Boolean arithmetic. Okay. Now here's why you need to know that. If I went to my friend's house and they had two donuts, they had the jelly filled and the chocolate covered, and they said to me, you can have the jelly filled or you can have the chocolate covered. The social expectation is I would only take one donut. If I grabbed both donuts and shoved it in my mouth, my friend would be mad at me because I'm a pig. But in the Boolean system, I would technically be correct. See the difference between the way we use or socially and the way or in our regular life and the way we use or in logic. There is such a thing called an exclusive or, which means exactly one of them have to be true in order for it to be true. We don't use that very often. Okay. And then the last operation is not the not operation, so not A. So not true is false, not false is true. And I'll talk about why you would want to use the not operator in your Boolean tests in a little bit. Okay, so what formats do we have? Let's see. Let me open up. I just need simple notepad for this. Okay, so if I do if, and then I have my Boolean test, open curly bracket. Okay. Let me see. Let's presume I have. Let's presume I have already gotten values for A and B. Okay. Okay. Is that a complete if then else statement? Will it compile and will it run?
I think it will, but it won't give you anything of value.
Right. It will compile, it will run. And here's what it says. If A is greater than B, do nothing, else do nothing. So instead, we'll put some stuff in here. This is not code, clearly. Okay. That's how they normally look, right? Now,
Yes.
if I did that, could I do that? Am I allowed to do that? Yes, it is useless. Well, it's good for class demonstration. That's its only value.
Technically, yes.
Technically,
But
yes. Would you do that?
No.
You would do,
Still
whoops.
want to put something there because if you just left it blank, it would just come up with a blank screen and it would look kind of like a bug.
You would do that instead, right? In other words, what if you want to do nothing on the false branch? Can you just drop it off and leave it off? Is that allowed?
No.
Yeah.
Yes,
Oh.
you can do that. Yep, you can do that. You are allowed to have only one branch. You're allowed to do that with something in it, and you are allowed to do that where the else block is there, but it's empty. Now that's I'm not going to say stupid thing to do, but it's a stupid thing to do. But if you don't have anything to do on the else block, you just you just omit it. You don't need it. Oh, MATLAB, come on, MATLAB surely will let you not have an else block.
No, you need to have an else block or it gives you an error message. And then you also need to have end on MATLAB.
Yeah, but
No.
what if you put end there? Doesn't that work?
Yeah, you can just do if and.
Yeah, I would think so. I would be shocked if MATLAB didn't allow you to do just a true. But you have to put the end up front. Okay. Now, what about this? Can I do this? Do nothing on the true block and something on the false block. Will that compile? And will it run? Yes, yes. I'm getting a lot of yeses. Are you sure? Have you tried it? Yeah, exactly. Nothing is something. That's correct. Yeah. If you do this, it'll compile and it'll run. There is nothing syntactically wrong with this statement. Having said that, never do it. Never do it. It's bad programming. It's bad design. It's confusing programming. So don't do it. Don't do it. If you have something like this where the action occurs on the false result,
You could flip the condition.
that's what the not operator is for. We could do something like that. By the way, in this case, I could just flip from a greater than to a less than, right? Less than or equal to. But in this case, that's why you use the not operator. Sometimes you can't just flip the thing, right? But the point is you have to change. You always want to have that Boolean test set up so that if you know that if the Boolean test comes out one way, you're going to do something. And if it comes out another way, you're not going to do anything. You always want the action to occur on the true result. And then I only have a true branch and all is well. Okay, so that's what the not operator is for. Because we always want the action to occur when we get a true result. I guess this would make more sense if this is equal sign. Okay, so this is just examples of that. You're allowed to have all of these things. You're allowed to have an empty true branch with a action taken on the false branch, but never do it. Remember, we want to write clear code, good understandable code. Okay, can you now nest these things? And I think everyone who's gotten into this class had to take, CS118 or CS225 or EGR115, and I would be shocked if you got through those without having to do a nested if somewhere. So you can put if statements inside of statements. This shouldn't, when you start to think about it, this doesn't surprise you, right? So what goes inside here really are program statements, right? So if I have if, I do program statements. Is an if then else a program statement?
Is it a condition and not so much a statement?
It's a form of a program statement, right? If then else is considered a form of a program statement. So if I'm allowed to put any programming statements inside of my true block, couldn't I put another if then else inside there? That's where we get this nested if stuff. Yeah, think of them all as types of programming statements, forms of programming statements. Now the if then else, the form of the program statement is somewhere it has to have a Boolean test, something to do if it's true, something to do if the test is true, something to do if the test is false. If you can unify concepts in your mind, there's less to remember, right? They're all just programming statements of different forms. All right, so you can do this. If X is greater than Y, if X is greater than Z, so you can do this nesting. Now, how much can you nest? Could I put another one inside, right? Could I have gone inside here and put another if then else in there?
Yes.
Yep. Now, some programming languages limit how often you can do that. And quite frankly, they should. How deep can you go? How deep should you go? If you have a bunch of nested if then else statements, almost always that means what you've got on your hands is lousy programming. Almost always. Every once in a while, it means you're just stuck. You're just kind of screwed. You're in a bad situation, and the only way to do it is with all these things. Yeah. Right. So if you find that you're doing these long chains of nested if then else's, come and talk to somebody, and maybe we can figure out a cleaner way to do it. Hence the cartoon I chose for this section at the beginning. All right, so by the way, for commercial software, people take large pieces of software and study them. And there are groups of people who will gather software from all over the place and then analyze that software. And how many lines of code? What's the average number of lines of code in a particular function or method? Or how many objects do you have? You can do all this analysis on the code. And as of this, my information is a little bit old, about 15 years old. But for large pieces of software, the average nesting, the deepest nest that occurred anywhere in that software on the average was I think 3.4. So about 3 levels deep. This is 2 levels deep. So there would be one more if then else inside there. But those are large pieces of software. You probably don't need, probably you don't need to go any more than 2 layers deep for your code. And even then you may find ways around that. If you find that you're going if then, if then, if then, if then, you may be able to convert to a switch statement. We'll talk about that in a second. I'm sorry, I forgot I got this. Okay, now the variation on this is, yeah, you may be able to convert to an else if, or you may be able to convert to a switch statement. So we have if, else if. Now, what's the difference between the if then else and the if then else if?
If
The
else
else
if
have
has more than
conditions.
2 conditions.
Right, so that's the normal if then else, if then else. If then else is, else if has another test. There we go. So you're allowed to add another test in there. Now, does that mean that if then else if is more powerful than the if then else? Can it do more?
Yes.
Notice I'm not agreeing. It seems like it, doesn't it? No,
It's just
It
doing the
has
same
like a
thing.
it's
more diverse
doing something.
application.
You're right. You could do the same thing using just if then else's, and it would be uglier. So this is a cleaner way to do it. It does not give more power to the if then else statement or the if then else construct. It gives a better look for the programmer, ease to the programmer. So this is an example of syntactic sugar. It does not add computational power or ability, but boy, it's a lot better to program. It seems like it would be more powerful, but it's not. You can do the same stuff with the bare bones if then else's as you can with if then else if. And in fact, the way you would do that same thing. But it looks uglier, right? Okay. The thing about the else is you can chain a bunch of them if you want to. So that's nice. If you start to get a long chain, though, you might consider trying a switch statement. And unfortunately, the switch statement is really great in some ways and very restricted in usage, though. The switch statement says, hey, if I know that I asked I have a particular method or a particular attribute, and it can only take on a small number of values, then I can break this down into cases. Oh, Carson, my definition of power is the pure computational, the definition of computational power is defined in computer science, meaning what can a computer do? Can a computer do more with if then else ifs than it could with just if then else's? And the answer is no. That's my definition of power. Oh, don't get me on a rant here. Okay. So the idea here is you say, okay, I'm going to break it down into cases, So think about your standing. You're either junior, sophomore, freshman, sophomore, junior, senior. That's only 4 cases. We could assign numeric values to those, 1, 2, 3, 4. And then when it says, hey, what class standing are you? Oh, case 1, if you're a freshman, do some stuff. Case 2, if you're a sophomore, do something else. So this is, again, if you look at it, it doesn't look like an if then else at all, but it's a way to do an if then else in a cleaner way. Okay, so this is just the formatting of it. You switch and you're naming a variable or an attribute. You're not asking, is it greater than or equal to or whatever. Switch X, and I'm saying X is my variable. And then if X is equal to 1, we do this. If X is equal to 2, we print out evers. If X is equal to 3, we print out chance. Now, it may be that X is none of those things, so you can have what's a default condition in your switch statement. By the way, in your switch statements, always have a default condition. Now, what's this break about? If case 2, it prints out evers and then breaks, meaning it breaks out of the switch. If you don't have these breaks, you don't have these breaks, then what happens is if you have case 1, it prints out tinkers, but then it also goes through the rest of the switch construct until the bottom. So if your case X was equal to 1, it would print out tinkers and then evers and then chance. If you do it this way, if case 1, it only prints out tinkers. Okay. Let's see. Okay, we'll get through this, then we'll do a repetition on Wednesday, and then we'll do the code examples, which are really stupid silly. How do you combine things? If you wanted to combine things, if you have 2 Boolean tests that have to be true at the same time. For example, if you want to get in the accelerated master's program, you have to have a GPA of 3.2 or greater and at least 80 hours towards your degree program. So if I have GPA of 3 greater than or equal to 3.2 and I have number of credit hours greater than 80, I can get into the program. So that would be 2 tests that would be combined with the AND statement, or with the AND operator, I mean. And what's the AND operator? It's the double ampersand. The OR operator is 2 vertical lines, which are on my keyboard above the enter. That would be the OR operator. And you should read them that way. If X is greater than Y and X is greater than Z. If I put the OR in there, if X is greater than Y or X is greater than, just read them that way. Now, sometimes you have these even more conditions. And my recommendation is if you start to get a really complicated Boolean test up there, make a method. Object-oriented programming is all about making methods to do small little things. Some people recommend never putting your test in there and always having a method call where the method returns a Boolean. So instead of having this kind of thing inside here, which could be tough to read, I would have my Boolean test as a method call instead, and I would name it what it does. In my example what was my example? Getting into the accelerated master's program. In my example there, maybe I would name that thing has met accelerated master's criteria. Long name for a method, but you can get an idea of what the method is doing. And then the method returns a Boolean, because remember, it has to be true, false as an answer, returns a Boolean, and then you put this mess down in here. Why is that better? You still have that mess, right? Yeah, but you have the mess hidden away, so if someone's reading through your code and they get to that if then else statement, they don't have to stop and say, oh my God, what is this mess? What are they trying to do here? They just read the name of the method and they're like, oh, okay. Now later on, they can check to see if the method was done correctly. Okay, let me point out, by the way, I put up 2 pieces of code for sample code, this module. And I'm trying to get you guys used to thinking in terms of objects. So I created one class that just has some if then else examples and repetition examples. And then I built another class that controls it. So this class builds, where is it? Where is it? There it is. I build an object of the examples class. I call it OBJ for object. And then I exercise that thing. I run these methods. And what are these different methods? Basically, I'm giving you a simple if then else, and I'm giving you a simple if then else if, And I'm giving you a simple for loop and a simple while loop, which we'll talk about on Wednesday. So that's all these are just, I don't think I have any entries yet. All these are just, you know, stupid, simple examples so you can see the syntax. And for the switch statement, I put that over here. So here's an example of a switch statement. And I'm telling the user, you have to give me an integer value between 1 and 4. So notice I've got a very small set of possible values. So I can do case 1, 2, 3, 4. And then the default is, you know, hey, I told you 1 through 4. Okay. All right. Before I go, I'm going to get back to this. Depends on your definition of power. I get so mad at commercials where they're trying to sell you laptops and computers because they say this computer is more powerful. Bull. They're faster. They have more memory. They have no power in terms of computation. The same computations that one computer does can be done on another. It might take longer, might be a little slower, but it can be done. So don't be tricked by the commercialization of the word power. More memory, faster chips, higher resolution screens. Boy, that's neat stuff and we all love it and that's good. But in terms of increasing the capability of what a computer can do, it's really not anything. What it means, it can do it more conveniently, faster, in a way that you enjoy more, but it's not an absolute growth in power. And with that soapbox statement in class, since we're at time. Yeah. Organic. At least there's some standards for organic. There's standards for power, but it's only in the computer science community, so the commercial world ignores it. Okay.
All right, thank you. Have a good one, Professor.
Thank you. I'll see you Wednesday. We'll finish up these slides and get into the code. The code will not take that much time to go through them. Inefficiency of code. God, there you go. So let's say the word efficiency instead of power then. Good point. All right, guys. Have a good one.
I have a question.
You may.
Okay, you said that you posted sample code.
Yes. Let me write it for you.
Okay. So is that under our modules?
Yeah, everything's under modules. Yes. This is module 3. And you go to selection, repetition, discussion, and right there, M03.zip.
Module 8?
3.
3. Okay, I see it.
Got it?
Yeah, thank you.
The code will always be inside the modules.
Alrighty.
All right.
Thank you.
Bye-bye.